I'm really sorry I turned you off. Oh, for Pete's sake. Okay, my little comment to myself was go back to partially filled arrays. Why would you care about partially filled arrays? Partially filled arrays, when you don't know the amount of data that your array is going to hold, then you have to allocate it to be larger than the maximum set of data that you expect it to hold. What does that mean? Well, if I don't know how many tests I'm going to give, then I better not only give myself space for 5 exams. Because then what if I need 6 exams, right? So typically what you do is, you kind of think, well, I need the space for 10 exams. I'm going to double that just to make sure that I have enough space. Now, this seems a little bit wasteful, but really that's about the only way that you can handle it with arrays. That's why there are other data types other than arrays that are better suited for such. Lists, for example. So let's make a little application that just lets you enter data. You know what, we ought to even fill it full of random values. That might be kind of fun so that we don't have to type it in each time. So let's create an object of the random class. We're definitely going to need java.util.asterisk up at the top. Import java.util.asterisk. That'll give us our random class back. I did not mean to make this random object part of the lecture class. It should be a local variable inside main, or it better be a static variable so that main can get a hold of it. All right. So what are we going to do? We're going to write a program that rolls 2 numbers, and if they're equal, then it stops. If they're not equal, it adds that value to an array, just like we were going to ask, the user to type in a value, and we were going to quit when they typed in -1. So let's declare 2 variables to hold random numbers. Int r1, r2. Right, like die rolls, die roll 1 and die roll 2. So we need some kind of for loop, and we need to allocate our array. Well, the length of this array kind of depends on how long, the size of the dice that we need to use. When I say size, I mean the number of sides. Like if you're a D&D player, you're Dungeons and Dragons or Pathfinder, you're used to 6-sided, 12-sided, 8-sided, 20-sided, and so on. Everybody else in the world just uses cubic dice with 6 sides. If you're trying to check to see how many rolls match or equal to each other, then it's like if it's a 6-sided die, then it's 1 out of 6 rolls will match on average. If it's 10-sided die, then 1 out of 10 rolls on average will match. So if we're going to roll until we get a matching set of dice, then it definitely matters how many sides our dice are. I think that was bad English. Anyways, so why don't we do this? Int sides equals 20. We're going to roll 20-sider dice. One of 20-siders, they're technically called icosahedrons, right? They look like that. Yeah. So we're going to generate numbers between 1 and 20. So let's do this. R1 equals R&D dot next int parentheses, in parentheses, semicolon, but inside here we're going to do sides, and that'll be a number of up to 1 to 20, but actually it'll be a number between 0 and 19 because this upper bound is non-inclusive. So that's a number between 0 and 19, and we need to add 1 to it. Oops, get rid of that semicolon there, in order to make it 1 to 20. Will be 1 to 20 or whatever sides is. R2 is the same. Why don't I just copy and paste that and change it to say R2? So if the roll is equal, we don't want to add it to our array. How long is our array going to be? Well, let's just make it 20 long, right? That's sometimes not going to be enough. Sometimes we'll go all the way past the end of the array without, without ever rolling a double. But we may have rolled a double right on the very first roll. We need an array to store these values in. So let's make an array of ints. Int, square brace, in square brace, totals equals new int square brace sides in square brace semicolon. And we need a variable to indicate how many we have added so far for our partially filled array. Let's go look. Let's go check out partially filled array. They called it filled elements. I'm going to shorten that to just filled. So int filled is equal to 0. And each time we add a new element to our array, we're going to increase filled by 1. Just filled plus plus. All right. So let's do it. If they're doubles, that will mean R1 is equal to R2. So we're going to write our while loop while R1 not equal R2. While R1 not equal R2. Then add it to our array. Totals subscript I, nope, just total subscript filled in subscript, and it's messing all up because I typed in something wrong. Single square braces. When I say subscript, I mean single square braces. Totals subscript filled is equal to R1 plus R2. Don't ask me why we're stopping when we roll a double. Whatever. Right? This is just an exercise. And then filled plus plus. We want to add 1. That indicates how many pieces of data we have in the array. If we roll a double right off, filled is going to be 0. There won't be any data in it. It's possible that we won't even get our match within 20 rolls, in which case it's going to generate an exception. Why don't we put a print statement here just so that system.out.println parentheses filled plus a space plus R1 plus R2. You know what? I'd rather print that out before I add 1 to filled, but I think I'm going to leave it like that. All right, it blew up. Okay, for one thing. I don't even know what it's doing. Where'd that come from? Oh, I never roll the dice again, right? I only roll the die 1 time. So copy R1 equals R and D and R2 equals whatever, and paste them and put them down here underneath that print statement. So it was an infinite loop because the condition never changed, right? I never generated new values of R1 and R2, so if it was okay the first time, it stays okay and the loop never exits. But we did see it crash. I wonder what this is. This array is only, yeah, I know, it's only written 2, whatever. Okay, that time it added, what's this exception business? It's mixing our output with the error messages. And we don't have a space between our numbers, so we're not really seeing what we're rolling. So why don't we add that? So R1 plus quote, comma, quote, plus, or yeah, quote. That way we'll see a number between them. Okay, there we go. And that time, it only took 9 rolls before we rolled doubles and quit. Again, it took 9 rolls that time. That time it went all the way to 20 and it crashed because we didn't roll doubles 20 times, and so when it tried to add the 21st element to the array, it crashed. So what should we do? We should break out of the loop. This is wrong, isn't it? Let's get rid of that. We should break out of the loop when filled is equal to the number of sides. We should keep going only while filled is less than the number of sides. So the symbol for and in this language is 2 ampersands. Ampersand, ampersand, filled less than sides. And then let's do system.out.println and just print out the number of filled, right? System.out.printf, parentheses, quote, filled equals %d, comma, sides equals %d, \n, end quote, comma, filled, comma, sides. Sides is also substituting as our array length. So sometimes we will get it, and sometimes the array will be completely full. That time it only took 2. That time it took 4 times. That time we went all the way to the end, apparently, without getting doubles. You know what, I guess it would have been nice to print out what we rolled each time so that we could see, you know. Anyways, it doesn't really matter. Sometimes the array is filled, sometimes it's not. This one only has 4 out of 20 elements. If we write a loop to print out the array, we're only going to see 4 values, and the rest of them are going to be 0. May as well do that. Let's print out the array. Wasn't there an arrays to string method that we could use? So system dot, this keyboard really is weird. I'm going to bring my own keyboard someday. No, I'm not, but I'd like to. Println, parentheses, quote, totals equals, end quote, plus arrays dot to string parentheses our totals array. So inside the parentheses, totals. I'm going to go ahead and run it just to see, make sure it works, and I'll bring it back. Okay, see, this time we got on the first shot, so the rest of the array is empty. Why is it a problem? Why is it of interest that the rest of the array is empty? What if we wanted to average a number of our rolls? Well, we should only count 18. We should not add all these zeros to our average. It'd be like your prof, and you took 3 exams, and for some reason he divided your score by 20 rather than 3 when calculating the average. I keep doing that. All right, there we go. So if we're going to step through this, we can't just step through 0 through 19, right? We can't just count I from 0 up to the number of sides if we're going to calculate the sum or whatever. If we're going to print all the values but leave the zeros out. Well, could you just use an if statement and check to see if that value is 0? Well, what if 0 is a valid value, right? Somebody may actually score 0. Not on our die rolling program, but whatever. So what we want to do is we want to count up to filled. For int I equals 0, semicolon, I less than filled, semicolon, I plus plus, curly brace, system.out.printf, parentheses, quote, totals, square brace, %d, in square brace, equals, %d. See what we're doing here? We're making it look like the array statement here, but we're going to fill this in with I right there, and we're going to fill this in with that value. So after the end quote comma, we want to print out I and totals subscript I. And we could calculate the sum and the average if we so chose. So we saw using a for each loop to step through an array, I believe, but you can't use a for each loop to step through a partially filled array, or at least the idea is a little bit weird, because for each automatically goes all the way to the end. How do you know when to stop? You could come up with some convoluted way of doing it, but really you're not going to use a for each. Okay, so this one only had 2 elements in it, as we can see. Filled was equal to 2. That was how many elements it had. Wow, it rolled a double in the very first roll, so we don't have any data in our array. That time, we had 3 rolls until we got a double. You get the idea. Eventually, we're going to get to the point where filled is equal to 20, and the entire array is filled with good data. Well, we got close. Well, that may have been it. That may have been it. Okay, right? The array is good all the way to the end. So we have a totally filled array here. The rest of them have been partially filled arrays. Hope that makes sense. And sure, if we wanted to calculate the sum and the total and stuff like that, I like to declare my total variables as doubles so that I don't have to worry about integer division or rounding down. So double space total equals 0 semicolon. And then just copy that for loop. I don't even feel like typing it again. I'm lazy. Copy it, but delete the print statement and replace it with total plus equals. Right? So paste it and replace this with total, totals. Wait, I have 2 variable names that are too close together. I'm not digging it. I'm going to call this sum. So double sum is equal to 0. And then sum plus equals totals subscript I in subscript. Right? That'll calculate. And then we can calculate the average. Calculating the average in this particular case is risky because we've seen examples of when the array had 0 data, and so filled equals 0. And if we divide by 0, it's going to crash. But let's do it anyways. So double average equals 0. And let's just check. If filled is greater than 0, if filled is greater than 0, we're going to calculate the average. It's not quite accurate if you don't have any data to say that the average of all that data is 0, but it's better than anything else. So if filled is greater than 0, then the average is equal to the sum divided by filled, which is the number of items in the array. And we could print those out. System.out.printf, parentheses quote, total equals %.2f, comma, average equals %.2f, \n, end quote, comma, sum, comma, average. And I guess if I use the word sum over there, I'm going to use the word sum over here as well. All right. I expect that's right. 1956. I don't know. 17. I guess that's right because the average of one 20-sider rolling would be 10, so the average of 2 20-siders rolling would be about 20. All right. What if we change it? What if we change it to that we're rolling only 6-sided dice, cube-shaped dice? Fortunately, that's pretty easy. We just come up here and change that, right? Much smaller numbers. Hope that makes sense. Partially filled arrays are when you don't know in advance how many pieces of data are going to be in the array. The user may have the option of entering data, and they may be able to quit early. Type in score or -1 to quit. You can't predict in advance how many scores they're going to enter. You might have a maximum number. You better have a maximum number that's not past the length of the array, but you might not know how many. So a histogram. A histogram is a chart that shows the occurrence of something. Like if you were going to roll 2 dice, you might be familiar with the idea that if you roll 2 dice, you're going to roll 7s more often than anything else. Wish we could find one with numbers underneath it. Here we go. Right? Because there's more ways to add up to 7 than anything else. You could roll a 1 and a 6, or a 2 and a 5, and a 3 and a 4, or a 4 and a 3, and a 5 or a 2, and a 6 and a 1. Right? Lots of ways to roll a 7 if you're rolling 2 dice. Makes a bar curve. Well, you can use an array to keep track of how many times you rolled a 1, which would be none, right? If you're rolling 2 dice, you can't roll a 1. You can't add them up and get 1. But you can get a 2, you can get a 3, get a 4, get a 5, you get a 6, and so on. So, why do we do that? We need an array large enough to hold all the possible values. I think it's going to be sides times 2. And then maybe plus a little bit. Why? Because I would like to be able to go back to here. Oh, come on. Did I really close my window? No, here it is. I'd like to be able to call that, right? Really, this is array element 0, array element 1, array element 2, array element 3, and array element 4, and so on. I'd like to be able to skip that 0. So instead of saying sides, the array is sides times 2 length, it's going to be sides times 2 plus 1, because I really want to be able to go up to 12 in this particular case. So the array is going to have to be 13 long, because your index can be 0 up to length minus 1. So I need a new array. I think I'll just call it hist, H-I-S-T. Int square in square, hist equals new, int square, sides times 2 plus 1. We could even be filling this out while we did that other rolling. But meh. Now let's just write a for loop that'll add, that'll roll 100 times. So for int I is equal to 0, semicolon, I is less than 100, semicolon, I plus plus. That space is certainly not necessary. I'm going to come up and copy these roll statements. So I'm just copying R1 is equal to RMD and R2 is equal to RMD and pasting them. Now let's get the total. Total equals int space total equals R1 plus R2. And now, whatever that value is, like if it rolled a 2 and a 3, we want to increment the 5th element in the array by 1. Here I'm calling it total again. I'm going to change the name of that too. To roll, right? You've rolled 2 numbers and add them up. We've already used sum. We've already used totals. I'm going to go with that. All right. And then hist, H-I-S-T, subscript, roll in subscript plus plus, right? Take the element that is at that position in the histogram and increment it by 1 because we rolled it. So that's the first time we roll a 6, we're going to increment the 6th element. The second time we roll a 2, we're going to implement the 2nd element. Next time, we roll a 12, we're going to increment the 12th element. Now that's just about it, but let's print the array and take a look at it. So again, we're going to use that printf arrays.toString thing, or print string, right, print line. System.out.println, parentheses, quote, hist equals, that's going to be our histogram, hist equals, end quote, plus arrays dot with an S dot to string capital S parentheses hist in parentheses. And we better put a comment as to what's going on here. So above this top of this loop create a histogram of rolls. Roll 100 times, figure out how many times each number is rolled. Now 100 times isn't enough to make a perfect bell curve. You'd want to do it for like 1,000 or 10,000 or 100,000 times, but it's enough to show about something. So let's run it. There it is. Right, we didn't roll any zeros. We didn't roll any ones, right, because we're adding two dice together. We rolled twos 3 times in a row. Re-rolled threes 5 times in a row. Maybe if we were printing out the roll, it would make a lot more sense. So why don't we put a print statement here indicating what our last roll was. So I'm going to come here before the close brace and do system.out.println parentheses quote rolled a space end quote plus a roll semicolon, just so that we can see the numbers, not double quotes, semicolon. There we go. So I can eyeball my data and make sure that I like the way it looks. Oh boy, there's a lot of them. That's too many. I'm going to lower that 100. See, it should have been made a constant. I'm only going to roll 10 times, just for this test. So I change my for loop, I change the upper bound to 10, I run it, right? And so how many times did I roll a 9? Once, twice. And if I go and count, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It says I rolled 9 3 times. Oh, there was one at the bottom as well. Right. How many times did we roll a 10? Not even once. How many times did we roll a 11? Not even once. How many times did we roll a 12? Not even once. All right, I'm going to comment out that part because otherwise our output's a little bit too much, in my opinion. And I'm going to raise it back to 100. For I less than 100. And there we go. Now we could print a little bar graph, like made of asterisks or something, showing what the number is, and then how many times it appeared. So one line of them would have 10 asterisks, the next line would have 7 asterisks, the third line would have 10, and so on. But that sounds like a nested for loop to me. Because at first, like, the row is going to be row number 2, and then the columns, we're going to have 3 of them in there. The next one, the row is going to be 3, and we're going to have 10 in it. And the next one, row is going to be 4, and we're going to have 7 in it. So let's do that. Print bar graph of histogram. System.out. No, wait, what am I doing? We need a doubly nested loop. For parentheses int row equals 0 semicolon. Row is less than the length of the array. Yes, I could just reuse my calculation here. Sides times 2 plus 1, but why don't we ask the array its length? Hist dot length semicolon row plus plus. Now let's print out what row number we're on, right, so that we know. Well, let's do that in a minute. Let's do the doubly nested loop first. For int call equals 0, call is less than the value of that histogram array at that specific point. So call less than HIST square brace row in square brace semicolon call plus plus. And in here, let's just print out like a single asterisk or a single hash sign or something. System.out.print parentheses quote and asterisk end quote in parentheses semicolon. Now that's to print out one row. That's why we didn't make it println, because we want all these asterisks lined up on one row. But then we need to go to the next line, so we need a print line underneath here. System.out.println parentheses in parentheses. All right, this isn't going to be perfect. It's in the direction that I want it to be, but it's not perfect. For one thing, it's not going to have any labels, right? And another is it's always going to have some blanks at the very bottom, I mean at the very top, because you can't roll a 0 and you can't roll a 1. So that's why we have 2 blanks there, which looks okay in this particular case. But once you start printing labels down the side. Now that's kind of bell curve, but it wasn't enough to be a perfect bell curve, right? But if we change it to be 1,000, then these things are going to be 10 times as long. It's going to be a bit too much. Well, let's change it to like, I don't know, 500. And there we go, right? There's our bell curve. We could calculate it as percentages. Then it'd be a lot shorter. I think that's about as much as I want to do with that scaling. But we want to print columns. Excuse me, we want to print labels. So before we go into our inner loop, we want to print a number right there that indicates what the roll is. So let's do that before the inner loop. So system.out.printf parentheses quote %3d or %2d space end quote comma row. Which row are we on? In parentheses semicolon. Now why did I make it %2d? Well, if I didn't, here's what it's going to look like. Right, some of the numbers are 2 digits long, some are 1. So I'm using the printf and the format specifier to make sure that all the numbers, even if they're only 1 in length, occupy 2 spaces. So that's why we put %2d there. All right. Now we never roll a 0, we never roll a 1. Why are we even printing those out? Maybe we ought to just start at 2. Or maybe we don't mind. Kind of up to you, but I'd rather start at the minimum number. And if we were rolling 3 dice rather than 2, the minimum number would not be 2. It would be 3, and so on. So we might have to tweak it. If we were rolling 1 die, then the minimum would be 1, but it would no longer be a bell graph. We could prove that, but we're not. Let's come back over here and start our counter, our row number at 2, because we saw that we never rolled any 0s and we never rolled any 1s. So it's okay to start at 2 in my opinion. All right. Let's go back and change the dice to 20 sides rather than 6. So we're going to have numbers from 2 up to 40. It's going to be a lot larger graph, but the numbers are not going to get as high. Scroll back up the sides, and then I'll pause, make sure y'all are all doing okay. Change this back to 20. Run it. Right. It's a bell curve again, but it's kind of raggedy. We never rolled any 40s. It's okay. Only 1 out of 20 rolls. No, that's not even right. The chance of rolling 2 20s is not going to be really high. Why don't we, since we have more numbers, not make it a 500, let's make it 1,000. So for int I equals 0, I is equal to 1,000. We'll roll dice 1,000 times. All right. Still not a perfect curve, right? But I did get some 40s. I got 2 rolls of 40s. This time I didn't get any roll of 2. But if I keep doing it, I'll get it so that, okay, we rolled a 2 one time and we rolled a 40 3 times. That's a histogram. That's almost too much for a histogram, right? But it's a histogram. Bring the code back and make sure y'all are doing okay. So here's another example. Total cheese production in January. Our array would need how many elements in order to do this? It would need 14 elements. Or it only needs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I said 12. But in this particular case, I would probably allocate the array out to 14, just so I could comfortably use this counter as a straight index. Because if I try to minimize it and I say, well, really, I only want 12 rows, so I'm only going to do, in that case, this 0, 2 would have to be column 0, and this 0, 3 would have to be column 1, and 0, 4 would have to be column 2, and you'd have to be subtracting 2 from each one to get it to work. I like doing it the way we did. I don't mind having 2 empty columns in my array, 2 empty elements in my array. Can't even imagine what this is telling me. 2 through 13 what? Not days.
Does it end on 2013?
Yeah, it could be the years. That's right. Yeah, 2013. Okay, so 2002 all the way up to 2013.
The y-axis.
Yeah. What are you having to say about that down here on the hidden slide? Well, come on. Is there anything down there, or you're just hidden because you feel like being hidden? That seems to be the case. All right, so problem description. Suppose you have 3 coins. When you flip all 3, you're curious to see how many times you get 0 heads, 1 head, 2 heads, or 3. This is just like our die roller. Write a main method that simulates rolling the 3 coins 1,000,000 times. Okay, they're ambitious, 1,000,000 times. Print the results in the form of a histogram. For each of the 4 cases, the 0 heads, 1 head, 2 heads, 3 heads, print a bar that represents the number of times that case occurred. To mimic a bar, print a certain number of asterisks. So the number of times that we rolled no heads, they were all tails, was that many. The number of times we rolled 1 tail is that many. The number of times we rolled 2 tails is that many. The number of times we rolled 3 is that many. So this could be a 4-element array. 1, 2, 3, 4. And in that case, the size of it actually does match up, right? Because our dice weren't rolling zeros, so we were ignoring the 0th element of our array. But in this case, 0 is a valid value, the number of heads. Each element in the frequency array is called a bin. Now, I'd kind of forgotten that. I hadn't looked at this slide recently. What do you know? So each element in the frequency array is called a bin. So in our code here, when we ran it, that's bin number 0, bin number 1, bin number 2, bin number 3, and so on. I'm not going to ask that on an exam. After each simulation iteration, you add 1 to the appropriate bin. Well, I get what it's like a trash bin, right? And you're throwing stuff into 1, 2, 3, 4, or 0, 1, 2, and 3. Searching an array. To search an array, you got to start at position 0 and you keep going until you find it. And that's commonly written as a method. We might want to do that, write it as a method. But we could write the logic out first. We have an array called roles. Let's search, no, it was called totals. Let's search the totals array for the first time that a 2 is found in it. We're going to call that our target. And target is equal to 2. And let's make an annotation as to what this is actually doing. Search our totals array for the position of the first 2 rolled. Because it might be the first time, it might be the last, it might not be in there at all. We need a found at indicator. The found at indicator tells us whether we found it or not. I'm going to initialize our found at indicator to -1. Why? Because if we don't find it at all, we need some way of knowing. And returning 0 would not be a good enough way of proving that we didn't find it, because it really could be at position 0. But there is no position -1 in this language, so int found at is equal to -1. Now we're going to start our array right from the beginning, look through the end, and when we find an element that matches our target, we're going to set found at equal to that index, and then we're going to break. So for parentheses, int I is equal to 0. We could conceivably start it at 2 because, no, I don't think so. That array was completely filled, even the first 2 rows. Forget what I was saying. For int I is equal to 0, I is less than totals dot length, semicolon, I plus plus, and maybe I'd like to use a whole word index this time just because it looks a little bit nicer. So I'm changing those short single letter I's to the whole word index. Now let's compare that specific value, that specific element to our target. If, parentheses, total subscript index in subscript equals target, we found it. So curly brace, found at equals the index, that's the position we found it at, and then break out of the loop. Conceivably, we could just keep going, but this one finds the first occurrence. Search our totals array for the first position of the 2. Yeah, for the position of the first 2 rows. Right, if we weren't breaking out of it, we would keep going through the array and we might find another example and another example and another example. So found out would eventually equal the last time that our target was in the array. If we wanted to achieve that, we would leave the break off. All right, and so after our for loop, after both of our for loops, once our for loop is closed, I said both, but it's an if nested inside of for. If found at is equal to -1, it means we didn't find it. So if found at equals -1, didn't find it. So system.out.printf parentheses quote %d not found in array \n end quote comma target. Right. We're telling them what the target we were looking for was, and we're telling them that it was not found in the array. Oh, else, open parentheses, system.out. And we're going to tell them what we were looking for and what position it was found at, what index. System.out.println parentheses quote %d found at index %d end quote. Oh, come on. \end quote comma target comma found at. I seem to have made a mistake in my statement here. Oh, because it should have been printf, not println. So if we run it and there are no 2's in that roles array, the original one, then we're going to find this message. Else it's going to print out what position it found it at. So 2 was not found in the array. If we scroll way back up, we'd look, and sure enough, no, that's a histogram. But here's the 2. We never found, they never added up to 2. Let's run it again. 2 is still not found in the array. Let's run it again. Okay. Will it ever find 2? Maybe I should lower the size of the die, so to get 2 more often. Right, if you're rolling cubes, you're more likely to, add up to 2. Okay, it's not finding it at all, so why don't we do that? I'm going to come back over here and I'm going to change my sides back to 6, so it's more likely that I will have rolled a 2. Okay, think about it. Why is it not finding a 2? What is this array actually full of? Our first array, the partially filled array. What was our stopping condition?
A double.
A double. And what is a 2? It's 2 1s. It's a double. So it'll never find a 2. We have to look for an odd number. That explains it. Why don't we look for a 3? I'm going to change this back to 20-sider then. Int sides is equal to 20. I'm going to come down here and just look for a 3. And I'm going to add a comment that this is our search value. Search the array for this value. And here, where I have 2 there, I do feel like editing that to make a little bit more sense. For the array, search our totals array for the position of the target. Maybe I should say first position of the target. Okay, get better. Okay, finally. We got a 3. The very first number it rolled was a 3, right? A 2 and a 1 added up to a 3. This time 3 was found at position 17. We could count it over and we would see that it was that particular roll. A 1 plus a 16 or whatever it was. Not spotting it, but whatever. There, that one. Position 17. This is the 18th spot, right? Because it's not zero-based indexing, but it's the 17th element of the array. All right, I hope that makes sense. Let's turn this into a method. Here's the really cheap way of doing it. Highlight everything from here, from this for statement, all the way down to the end of the loop, and refactor it. I'm going to immediately undo this, so I'd actually kind of like for you not to do this. But I'm just showing that you can. And I'm not spotting it. Introduce a method. And it makes a method out of that. So I could call my method search array. And look what it did. It created a method that accepts my array, what I'm looking for, and it wanted found at passed in. Strictly speaking, it wouldn't need that, and I would probably rewrite it so it didn't. So it doesn't do a perfect job at it. But if we right-click on this and do navigate, go to source, here it is. It changed that code that I highlighted into a method. Neat. But we can do that manually. Let's do it manually. Let's rewrite this. So I'm going to come up to the, well, I could put it at the top or the bottom, doesn't matter. Before the final close brace, let's just call this search array. It needs to return an int of the index. So int search underscore array. It's going to take an array of ints. So int subscript in subscript AR, comma, and it's going to look for a target. Int target in parentheses. Same business. We need a found at, but let's add a comment. Returns -1 if target not found in array, else the first position, first index of that target. So int found at equals -1. That's our indicator it wasn't found. And then for int I equals 0, semicolon, I less than AR dot length, semicolon, I plus plus, if, parentheses, AR subscript I equals target, then we found it. We could just return right then and there. We don't even need a found at counter if we do it that way. but let's go ahead and make it look the same. Found at equals I, semicolon, and then break, semicolon. And down here at the very bottom, in the semicolon after the for loop, that's our end for, we're going to return found at. So if we were going to use that up here underneath my system.out.printf, int which underscore index equals search underscore array, passing in my totals array. Come on. Totals, comma, and I'm searching for a 5 for whatever reason. It's not liking that. Real obvious reason, but does anybody spot why it can't find this method? It's certainly a member of the class, so that's not the problem.
Is it because it's after?
It's not that it's not positionally dependent, unlike Python and C++ where it is. It's because this is a static method, and so any other methods in the class have to also be static if they're going to be called. So it should be static int search array. All right, and let's print the result of that one as well. If we went to the trouble of finding it, let's print it out. So %d found at %d, that was the target. Oh, no it wasn't. Fine. Above this I'm going to say target is equal to 5. No, I'm not. I'm just going to change my print statement. And I'm going to put a 5 here, right? 5 was found at index, then it's kind of lame. End quote, comma, and that our variable was called which index for this one. And it didn't seem to print it out. Oh, I know what I did wrong. That print statement is part of an if block. Right? It's inside that else. Heavy sigh. Cut those 2 lines. Paste it before the last of the method. This is the end of main here. Paste it. And we need an if statement which checks to see if which index was equal to -1. It wasn't found. If parentheses which underscore index equals -1 means it's not found. System.out.println parentheses quote 5 not found in totals array. End quote in parentheses semicolon. Else do that one. And I'm going to tidy things up a little bit by removing those curly braces. Same business up here. Why not remove those 2 curly braces and these 2? Now surely I've messed someone up now. All right. So the 3 was not found, but there was a 5 found at position 10. Right there. Syntax errors. No fair, guys.
Still typing. Ask me again in 30 seconds.
Can you go up a little bit?
Sure.
What we were just at.
Right there?
Yes.
Okay. All right, say we wanted to sort our data. As a matter of fact, why don't we sort it even before we start doing all these searches? And let's just sort it here. All right. So arrays dot sort parentheses totals in parentheses semicolon. That will sort the data. So if we print it out, we'll see what we got. System dot out dot print ln parentheses quote totals equals, or maybe make it say sorted totals equals end quote. No comma there, that's Python. After the end quote is a plus sign. Arrays dot to capital S string parentheses totals. That's after the sort. Then what if we want to reverse it? Well, we can use arrays dot reverse. Arrays dot reverse parentheses totals, and then just print it out again. So I'm just going to copy that line, paste it, and change it from saying sorted totals to reverse totals. And what do you know? There is no reverse method. What is it really then? Ooh. Copy of equals fill parallax sort set all sort splitterator. I like that one, the splitterator. String. Well, what do you know? I'm totally amazed that there's not a reverse the order of Java array. You have to write a method to do it using arrays list. Okay, fine. No way to easily do it. But we may as well print out the sorted total. I mean the sorted array anyways. So let's do it. And we probably need to wrap it up. All right, and so now it's sorted. All right. So when was the last time we had homeworks? Because if we did one Thursday of last week, then I might be willing to not have one today. Okay, yeah, we'll hold off. Although realistically speaking, surely I have. Nah, we'll hold off. Alrighty, so let's make a Dropbox and we'll be done for today.